let's get going. So if you look at kind of what we need to do in this topic, in the first week, we talked about solving quadratic equations by factorizing. And today, we're going to start to look at something called completing the square. And completing the square is a process that we need to learn, but we don't want to overuse it. It's like a tool that you use on a particular occasion, and you want to feel comfortable learning how to use it, but you don't want to overuse it either. And so today I'm just going to focus on teaching you this thing, and it's actually really not that hard, but we need to go through the steps. So step one today is going to be, if I square a binomial, can I observe what happens? So when I say a binomial, I mean an expression with two terms. When I say squaring a binomial, I just mean that I take this expression with two terms and I square it. But you can write squaring a binomial like this, or you can write it like that. Give me a thumbs up if you understand why these two things are the same thing. Okay, fantastic. So now, what I'm going to do is, back in grade 9, you learned about something called FOIL, or multiplying out brackets. And I first want to show you, if I multiply the first inner, first outer, so I'm going to get x squared plus 5x, but I'm not done. This has to be multiplied, and that gives me plus 5x plus 25. And you'll notice that this idea happens a lot. We get the x squared term, which stays the same, but then we have these two middle terms over here, and there always seems to be two of them, and that gives me 10x. And then over here, we have 20 plus 25. So that's called squaring a binomial, and we end up with three terms, and it's almost like we just square the first term, we square the last term here, the 5, and then we have this two lots of this thing here, and we get that. I want you to now, so I've answered that one. I want you to expand this binomial and square it and see what you get. And then I want you to put the answer in the chat when you've got it. Okay, so it's a knock-off. X squared plus 4x plus 4. Okay, the plus, I just need to check the plus signs because we need to be careful. I definitely get an x squared, but I get a minus 2x when I do that bit. So, and I get a minus 2x when I do that. And then I get a plus 4. Now, it's like interesting, the same little thing, the middle term is doing its funky little dance here, but we should get x squared minus 4x plus 4. Okay, give me a thumbs up if you're okay with that. Give me a thumbs down or unhappy face if you're not. There's definitely something to the squaring a binomial thing. I always seem to get like the first thing, like I can square that. And then there's a second thing and I can square that. But then the middle bit seems to be a bit more exciting. So we'll keep an eye on that. Now I want you to try and do the third one. Can you do that? And then I want you to pop the answer in the chat when you're done. Okay, and so welcome to a few more students. Babawa has joined us, and Danielle, and Mene, and Njabulo, and Orato, and Pila, Ribetswe. Welcome, everyone. It's good to have you with us. So I would like someone to talk me through the process for the third one. Who is feeling like they're generous? Who wants to share some of their knowledge? And again, it's not about getting it right. It's more about showing your perspective on things that everyone can benefit from. So just pop your hand up if you can talk me through this process here. Okay, let's go to, I see a hand. It's appreciate. Let's go to appreciate.
So firstly, what I did, I times x, the first x with the x from the other bracket, and then I multiplied the 4 from the first x. I mean, from the first bracket with
Like
the
this.
other x. Yes.
Okay. And then?
And then I multiplied the other 4, the first one, with the x.
Okay. And you got 4x
plus 4x
again. Okay, and then?
And then I multiplied 4 with the other 4.
And what did you get?
Plus 15.
Okay, awesome. Now, were you able to make this even simpler?
Yes.
What was your final answer?
X squared plus 8x plus 16.
Perfect. Perfect. Thank you. So guys, what I want to point out to you is that whenever we square a binomial, and I'm actually just going to rewrite this thing. Remember we said at the beginning, this thing over here is the same as x plus 5 squared. This thing over here is the same as x minus 2 squared, right? So if we look at that, let's just take a moment and check if we understand that. And then this one over here, this is exactly the same as this. So are we all happy that x plus 4 squared is the same as x squared plus 8x plus 16? Can you see the connection? Because remember at the very beginning we multiplied, but this is the same. And I want to just check if I say, do you understand? And maybe ask a question if you don't. Can you see that this is the same as this? And do you believe that this is the same as this? Give me a thumbs up if you do, thumbs down if you don't, and a middle thing if you don't see the connection. So basically, yeah, let me give you a moment before I say anything more. All right. Now, what you'll notice is the second line over here, right? The second line, this is a square. This is a square. This is a square. And so in order to go, this thing we're going to learn now is called completing the square. And we're going to use some of the ideas that we just saw in this example. So let me go here. Actually, before we even get to completing the square, we'll come back to that last bit at the top. I want to now factorize these trinomials. So these are 3 trinomials, and I'm calling them perfect square trinomials. You'll see in a moment. But I'll do the first one, and then you can do the second one. Okay, so this is a trinomial. To factorize a trinomial, there are different methods. The one method is to open the brackets like this and think about what goes in there. Another method that I was doing earlier on was this system where I said, look, that's plus 10. So this bit is plus 10. And then I say, what are the factors of the number in front of x squared? And they're just going to be 1 and 1. And then I have to choose numbers that when you multiply together, you get 25. And so what numbers do you think are going to go in this box for factorizing this trinomial? What numbers do you think are going to go in there? So I think that we have to look at this number here, and we can say, can't we say 5 and 5? And so 1 times plus 5 is plus 5. So I think this trinomial is x plus 5 times x plus 5. You can see that that's going to work out. And another way of writing that is just going to be x plus 5 squared. Now, I'd love someone to come online and ask me a question, but if you can do that, then I want you to move over and do this one and also do this one. Okay, but I'm going to wait for questions, and I encourage you, because I know some of you are maybe a bit lost, and I want to encourage you. I promise you, I'm not a big scary math teacher. You can have a conversation with me. We can talk about this, and then everybody benefits from the conversation. If you can do it, just go ahead and put your answer in the chat, and you can go from there. Oh, what's going on? So I'm going to keep an eye on the chat, see what you don't worry, Nicole. I'm glad you could join us. You can just catch the first 20 minutes of the recording. Okay. But it does happen. I know life happens. We are luckily a bit more flexible than your normal classroom, which is one of the benefits of tech. Okay. I think that has to be a minus. So this is going to be x minus 2 times x minus 2. Or we could write it as x minus 2 squared. So that is the second one. Now I want us to do the third one. Can you factorize this trinomial? Some of you might be able to see this in your head even. You might be able to say, look, I don't even need to do the working out. I know this is an x and I know that's an x. What's this going to be? It's actually just going to be that. Now, we can also write that as x plus 4 squared. And just to show you, I'm telling you the whole truth. X times x is x squared. 4x, then 4x, and then. And so you see the same pattern is happening each time, where when you multiply out, you seem to have these two middle terms that occur twice. Okay. Give me a thumbs up if you followed how to factorize those three. These are called perfect square trinomials because each of the answers was a perfect square. You'll see that all of these are perfect squares. So I want to see a smiley face or a happy face if you understood how I did it, unhappy face if you didn't, or a question even. And I am keeping an eye on the chat. Okay, so you've done the warm-ups, you've done the basics. You all know how to multiply out. You all know how to factorize. So let's go and look at what completing the square is. Okay, this is an expression. Is this currently a square itself? Yes or no? In the chat, tell me, is this a square or is it not a square? I want to see what the people say. What do you think, Buchle? What do you think, Laniko? Rebetswe? Ooh, Rebetswe. Remember, we want to have a pen and pencil with us. We don't just want to be watching. I love that you're watching, but we want to be working. We want to be working. Okay. Because we know if we're using our pen, our brains just learn better. Okay. It is. Well, I don't think it is a square because a square has to have that bracket, doesn't it? Like, it was a bit of a sneaky question because I was sort of suckering you into it, but at the moment it's not a square. Okay. But maybe if we do something special like completing the square, we can deal with it. So let me show you what we do. This is the sneaky thing. At the moment, it's not a square. But if I said to you, +1 minus 1, is that still the same expression? So yes in the chat if you think it is the same expression. No if you think it isn't the same expression. I want to see in the chat what you say. The people must vote. The people must vote. I want to see. Okay, well, it is the same expression because when you add 1 and take 1 away, that's the same as 0. So, I mean, in some ways you can say it looks different. But in terms of what's actually there, it's going to be the same. I mean, it's the same value because you just added 1 and took 1 away. Right? So if you think about that, now here's the sneaky bit. If I do this, I think, is that the same expression or not? Is that still the same expression or not? I'm being very difficult here, I know. It actually is the same expression, guys and girls, because I just put a bracket around it. If there was a 1 here and I multiplied this out, would the 1 change anything? Nope. So I'm being properly sneaky here, but I need to be sneaky to explain this to you. So step 1 was saying, look, if I add 1 and take 1 away, does that change anything? No, because it is +1 minus 1 is 0. If I then put a bracket around this, it's still going to be +1 minus 1 is 0. And so actually, this is still equivalent to the original thing. Now, I know that's weird, but give me a thumbs up if you kind of buy my argument. If you kind of understand what I'm trying to show you with this. Okay. Now, here's the completing the square part. I want you to ignore the -1. We're going to let it just hang out. I want you to try and factorize. What do you think that expression is factorized? So I want you to try and factorize that expression like we were doing already. We'll leave this one for now. So I put a +2 there. What do we think is going to go in the blocks? I want someone in my class to tell me what is going to go in the blocks. Who is willing to share their knowledge and wisdom with us? Pop your hand up and then I can. Who feels like they know what goes in the block? Okay, Leniko, let's go to you. What do you think goes in the block here?
I think it's going to be x +1 and x +1 bracket.
Perfect. That's exactly what it is. Thank you, Leniko. You're quite right. Now, here's the interesting thing. This is x +1. This is x +1. And if I rewrite this, what is this going to give me? It's going to be x +1 squared minus 1. Now, what's very interesting is, can you see all the equal signs going down the left-hand side?
Yes,
it's saying that, look, originally we started out life with x squared plus 2x. Then we added 1 and took 1 away, which did nothing. Then we added 1 and took 1 away, which did nothing. Then we factorized this. But you know what? I've ended up with a perfect square minus 1, which is exactly the same as x squared plus 2x. And that process is called completing the square. Now, what was the most important decision I made in this when I completed the square? Lanico, is that a hand up or is that just from earlier on? I just want to see if your hand is still up.
From earlier on, sir. Let me put it
Okay,
down.
no problem. Okay, so now, what was the most important decision I made to complete the square? Who thinks they know? You can pop your hand up or you can tell me in the chat. What was the big important thing that I used my ninja math teacher knowledge to jump ahead? You can do it. Just pull the trigger, guys. Don't have just the act of making a decision will help you learn. It's not whether you get it right. Who thinks they know? Put your hand up and just let me know what did I do that I must have known something that you didn't know? I want to suggest that why did I choose +1? I could have said +2 minus 2. Give me a thumbs up or happy face if you understand. The most important decision I made was to go +1 minus 1. So why did I choose that as opposed to any other number? There's so many other numbers I could have chosen. So give me a happy face if you see that like that was an important decision I made. Okay, now what I want to suggest is that there is a process that we follow. So I'm going to show you another example where I go faster and then it's going to get a bit easier. So let me go to this. Okay. Let's go to this. Okay. So if I look at this expression at the moment, is this a perfect square? No. Okay. In fact, sorry guys, I'm actually jumping ahead here. Let me go to this one over here. Now, is that a perfect square? Yes or no? It's not. Okay, but I'm going to be sneaky now. I have to choose to go plus something minus something. Okay? And if I choose 1 this time, it's not going to help me. So what I'm going to do is I'm going to tell you the secret formula. All you need to do is you go, what is the number in front of the x? And you divide it by 2. And you get, if you get 5 and you divide it by 2, we get that. And then what you do is you take that number and you square it. Now it seems weird, but at the moment, all I'm doing is I'm dividing by 2. So I take the number that's here, I divide that by 2 and I square it. Now, if I've added 5 over 2 squared, what do I need to do to balance the books? What do I need to do to balance the books? Lanico, let's go to you.
So it's gonna be a quadratic, so it must be equal to 0, and then what you do on the left hand side, you must do on the right hand side.
Yeah. So are you happy that if I suddenly add something, I need to take that same something away? Give me a thumbs up in the chat. If you understand that if I add something, I must take that same something away. Okay, now we're going to take a break now because we need to break this idea up into 2 parts. But the whole reason I did this was to complete the square. All right. So now what I'm going to do is there's going to be a square, and that square is going to be formed by this part over here. But this part on the end is just going to hang out by itself. What is 5 over 2 squared the same as in fraction language?
25 over 4.
Perfect.
Isn't it
Good. Okay. Are we happy it's 25 over 4? Now, what goes in here? Okay, now remember, we're just dealing with this bit. Are we happy that it has to be an x?
Yes, yes, yes.
Okay. Are we happy it has to be a plus?
Mm,
Because look here, it's x squared plus 5x plus 5 over 2 squared.
yes,
And
sir.
then the last bit is just going to be, let me put it in green, it's just going to be 5 over 2. And then we've done a much harder example of completing the square. Now, after the break, we're going to come back and redo this process, all right? But I just want to go over what was the key idea I did before we take a break. I looked at the middle term, I divided it by 2, and I squared. Then I took the thing that I had, and then I just randomly added. And because I added it, I had to take away the same amount so that everything was balanced. So that part basically is the same as 0. Then I left the pink bit, maybe I'm making it look too much like a graffiti wall, but I left the pink bit at the end, and I just did the completing of the square bit over here to get a square. Now, I know I will have lost some of you, so I want you to trust me and believe that when we come back after the break, things will get easier. Okay, but we need to take a break. So I want everybody's cameras on. Okay, well, let's do another one, because this process gets easy when you do it enough times. I want you to complete the square for f. For this expression. So I've got minus 4 over 2. And then I need to square that. And what's that going to give me? Minus 2 squared, that's 4. So I think what I'm going to have to do is I'm going to put the plus 5 down here. And then I'm going to add 4. And then I'm also going to what? I'm going to take away 4. Add 4 and then take away 4. That seems okay to me. What is my final answer going to be? So if we look at this, we have something squared, and then that's going to be a plus 1. So what goes here is x, and then what's going to come after that? Well, it's just going to be minus 2. Okay, and this number is it's always going to be this one over here. It's like this minus 2 is the same as this part out here. Okay, I think you're doing well. Now, I think what we do is we need something a bit trickier to spice up our lives here. Now, one of the problems with completing the square is it only works if the number in front of the x squared is 1. So let's go down to another example like, okay, let's take this expression here. And we're going to think through the process again. So I'm not going to solve it as an equation. I'm just dealing with it as an expression. Is this a square at the moment? Is this a perfect square at the moment? No. What is the first step that I need to do in the process? What is the first step I need? Where do I need to focus my attention? Okay. So it's going to be on the plus 6. Okay. Now, what do I need to do to that plus 6? So I take the 6 out, and then I divide it by 2. Okay. But is that enough yet? No. What do I need to do to this for it all to work out nicely? Okay, so I need to square it. Okay, what is this the same as? What's 6 over 2 squared the same as? It's 3 squared, which is the same as what? It's going to be 9. Okay, now, what I did in the last one that made life a bit more difficult is I didn't move this minus 12 down here out of the way. Now, what I'm going to do is I'm going to take this number. Can you all see that I'm going to add plus 9 here? But what do I need to do now to compensate for that plus 9? What do I need to do to balance the books?
-9, sir.
Perfect. So we know that the minus 12 was there already, but this ends up being nothing. Now, if we think about what's going on here, what is minus? So we have this bit over here, and we have this bit over here. What is this bit over here going to be the same as? What's minus 12 minus 9? Yep. Okay, now, here is the bit where we need to factorize this trinomial over here. What is this trinomial going to end up being? And I'm hoping it's going to be a perfect square trinomial because I'm using the completing the square process. Yes, Lenico, let's go to you.
It's gonna be x plus 3 squared.
Yes. X plus 3 squared. Now, if you look at my process, I want to show you again, just so that we know what the process is. I looked at the expression and I honed in on the middle term. I divided by 2 and I squared it and I get some number, which is this 9. But then the 9 has to be added to create the perfect square, but it has to be taken away again to balance that whole expression so that it still equals. So just give me a thumbs up if you've followed that one a bit more easily. And give me a thumbs down if you didn't follow that, if you still feel a bit lost on that one. Okay, let's do one more to finish today, and then we'll go from there. Then we sort of bank that knowledge for today. So we're not solving these at this stage. All we're going to do is we're taking the expression. Let me make this smaller. X squared plus 6x plus 8. So I'm going to block this out so you can't see it. And I want you to tell me, what am I going to do to start the process of completing the square on this expression? Where would I start? And what would I need to do? Sanako, let's go to you.
So wouldn't you take the 6 outside and then divide it by 2?
Yep, that is step 1. And then what would you do with that?
And then you divide. Oh, then you square it, sir. Put bracket.
Okay, what
then
do you
square.
get if you go 6 over 2 squared?
So 6 divided by 2, you get 3, and then you square the 3.
You get 9.
9. Yes,
Okay.
sir.
Now, the 9 is the magic thing that you need to add and take away again. So, are you with me when I say the following? I put the 8 down at the end, and I'm going to go plus 9, and then I'm going to go take away 9. Are you happy with that idea, that it's still the same expression?
Yes, sir.
Okay, now tell me what I do next.
I only know this bit, sir.
Okay, no, that's fine. You did very, very well. I'm going to hand it over to someone else. Who would like to tell me? There's going to be two parts. There's going to be a part over here, which is something squared, and then there's going to be another part at the end here. Okay, Bukle, what do you think? I'll try and unmute you.
So I think inside.
Oh, something happened there. I lost you there. Yeah.
I think inside the bracket it's going to be x plus 3 squared.
Yeah.
Then we minus the minus 8 plus 9, which is going to give us minus 1.
Perfect.
So that's going to be
So-
outside the bracket.
Yeah. So what we do in this lesson, so just to recap this process, and you can rewatch this lesson, and I will make a correction at the beginning of the next lesson on that one that was behaving a bit strangely. But really, when you have a quadratic expression and you want to ensure that there's a square there or complete the square, what you do is you go to the middle term and you divide it by 2, and then you square it, right? So you're always going to find the middle term, divide by 2 and square it, and then you're going to get a number. You're then going to add that number, and you're also going to subtract it so that the original expression is still the same expression. And then the expression is going to have two parts. It's going to have a part which is a square, and then it's going to have a part which is just a number. Now, this is a bit of a tricky concept, but I think if you go over this again and you just let it sink in, really what you'll see is you divide by 2, you square, and you add and subtract, and then from there you're good to go.